Understanding and controlling vehicle vibration is extremely important, not only from a driver comfort standpoint, but it also impacts vehicle durability and reliability. Understanding the source of vibrations is essential in order to begin to reduce them. There are many things that can cause vehicle vibrations, from the engine, transmission, drive shaft, axles, brakes, hubs, and tire wheel assemblies. And some vehicles are more sensitive to vibration than others. Vibration that comes from the tire wheel assembly can result from imbalance or from excessive runout or an out-of-round situation. In this video, we will concentrate on runout and how to minimize runout for a smoother ride, particularly those vehicles with high sensitivity. Even a properly balanced tire wheel assembly can have excessive runout and cause vibrations. Radial and lateral runout can result from improper bead seating on the rim or improper alignment of the component tolerances. Radial runout is the deviation of a tire wheel assembly's roundness from a perfect circle. This causes an up and down movement of the tire wheel assembly as it rotates. Minimizing the effects of radial runout is crucial to controlling and eliminating vehicle vibration. The steer axle is usually more sensitive to imbalance and runout than the drive axle or axles. Lateral runout is a deviation of the tire's sidewall from a perfect plane, which causes a side-to-side or wobbling movement of the tire wheel assembly as it rotates. Lateral runout rarely causes a vibration complaint, so we will focus on techniques to control radial runout. Mounting the tire on the wheel properly is an essential first step for acceptable runout values. Careful lubrication of the tire bead and rim flange area is critical to ensure the tire is concentrically mounted on the wheel. Always use a non-petroleum-based bead lubricant. If it is not properly lubricated, one bead or part of a bead is likely not to seat properly on the flange of the wheel or rim. Always check for uniform bead seating on both sides of the tire after inflation. Measure the tire in 4 different locations 90 degrees apart. The maximum difference should be less than 1.5 millimeter or 1/16 of an inch from the guide rib for the entire circumference of the wheel. If it's not concentric, you'll need to break down the assembly, re-lube, remount, re-inflate, and recheck the bead seating for the entire circumference of the wheel. In many cases, the practice of match mounting tires and wheels can be helpful in reducing the total runout of the tire wheel assembly. If by chance we mount a tire on a wheel and get the high point of the tire and the high point of the wheel in the same spot, the runout will be the total of the two. When these same component tolerances are indexed, you can minimize runout by using the component tolerances and having them work together, not against each other. Many truck tires have a red dot applied to the sidewall to indicate the high point of radial runout. This dot can be very helpful in trying to minimize assembly runouts. The red dot is located on one sidewall of the tire. There's no preference as to which sidewall is mounted in or out, as long as the red dot is aligned to the correct position on the wheel. Manufacturers of steel wheels often mark the low point of the wheel with a dimple. Align the red dot, or the tire's high point, with the dimple, or low point, on the wheel within 1 hour clock position. If the red dot is mounted on the intended inboard side, you may want to place a temporary mark on the intended outboard side to reference during installation to the vehicle. If the wheel does not have a dimple, find the wheel low point with a runout gauge and align the red dot to the wheel low point. If runout cannot be measured, align the red dot to the valve stem to use as a reference for vehicle installation. Alloy or aluminum wheels are manufactured using a machining process. Therefore, alloy wheels often have lower runout values than steel wheels and usually have no low point marking. When using the red dot to mount tires on alloy wheels, it is common practice to align the red dot with the valve stem within a 1 hour clock position to use as a reference for vehicle installation. By controlling the relative location of the component tolerances, you can help minimize on-vehicle runout during the tire mounting process. Once you have the tires mounted on the wheels using the red dot system, you are ready to install them on the vehicle. When installing the tire wheel assembly on steer and tag axles, index the red dot at the 12 o'clock position. This will improve on-vehicle runout by letting gravity take advantage of the tolerances between the wheel studs on the hub and the stud holes in the wheels. When installing tandem axle tire wheel assemblies on drive or trailer axles, place the red dots opposite each other at the 6 o'clock and 12 o'clock positions, or as close to opposite as possible while still maintaining valve stem access. This will help minimize vibrations and maintain valve stem access. Some drive or traction tires are not red dot marked. By knowing the best installation technique for the vehicle and tire wheel assembly you are working with, you can significantly help reduce or eliminate vehicle vibration during installation. If you have any questions or would like further information on the tips and techniques presented here, contact your local Goodyear commercial tire dealer or go to our website for additional information and suggestions.